Welcome to this video. In this video, we will see about the delta modulation working and its drawback. So, in delta modulation, it is an 1-bit modulator. Convert your samples into 1-bit data. So that quantizer, linear quantizer, is replaced by 1-bit quantizer. And instead of predictor, they're using the delay accumulator with delay unit, which will accumulate the previous sample values. So just it will compare the current sample with previous sample. If the current sample is greater than previous sample, the error is positive. If error is positive, the 1-bit quantizer, it will act as a limiter threshold device. It will produce the plus delta at the output, and it's given to the encoder, which will, if the plus data is generated, so it will generate the logic 1. The current sample is lesser than the previous sample, error is negative, the quantizer, it will generate the minus delta, and the encoder output, it is logic 0 is transmitted. This is a simple working of an delta modulator, and this is your characteristics of the 1-bit quantizer. It normally acts as an threshold device. It is having a signum function. So this is considered as an one analog signal, and it is sampled at equal intervals, which having some sample amplitude, and for each instant it will compare with your previous value. So this DAC is an output that is obtained from the accumulator and delay unit. It accumulates the difference, and it will generate the previous sample value for the current instant. And these two is compare, and it will predict the modulated output. It's either logic 1 or 0. So each sample is encoded into single bit data, and it is transmitted. And the receiver, it is from that 1-bit data transmitted, we are going to predict the sample amplitude. For that, we are using that same accumulator and delay unit. And finally, it given to that hold circuit, it will regenerate the analog signal. So this having two drawbacks. One is slope overload error, and the another one is a granular noise. So whenever the signal slope is greater than the DAC slope, so the DAC, it fails to track the signal envelope. So it occurs that slope overload error. At this cases, when the signal is having slow variation in the amplitude, so it continuously swing between that plus and minus, plus and minus. So it oscillates during this instant. So during regeneration, the signal is having some oscillatory noise signal, that's called a granular noise. So in order to overcome these two error, so we want to increase the step size or decrease the step size. If you want to overcome slope overload, we want to increase the step size. So quickly the DAC output, it extracts the envelope of the signal, then the slope overload error can be minimized. But if they reduce the granular noise, the step size can be reduced. So then only that oscillation levels can be reduced, so it can eliminate that high frequency noise effect. So these having, it's a trade-off between these two. One error, if you are going to minimize the one error, the another error will exist. So in order to overcome this error, we are going for that modified version of delta modulation. So that's all the delta modulation working and its drawback.